Welcome to the series on procedural cave generation. So we're going to be generating random cave shapes using a process called Cellular Automata, and from those shapes we'll then use another algorithm called marching squares to actually turn the maps into proper meshes which we can sort of have as objects in our game world. Alright, so to get started I'm going to create a new C# script which I'll call something along the lines of map generator. I'm going to create a new empty game object and just drag the map generator script onto that. Can maybe just call this something like map generator. There we go. And I'm going to open up the map generator script and let's just delete everything in here. So what we want to create is a 2D array of integers. So we just say int square bracket comma close square brackets map. And so this basically defines a grid of integers, and any tile that is equal to 0 in the map will be a sort of empty tile, and any tile that's equal to 1 will be a tile that is occupied by a wall. So what we want to do initially is just to fill this map up with random noughts and ones, just to give us a sort of starting configuration. Because how Cellular Automata really works is we start with this random configuration of walls and spaces, and then we sort of go over a number of sort of smoothing iterations in which we make each tile more like its neighbor, and we'll see exactly how that works when we get there. But what we'd like to do is just create a public integer which we can call something like random full %. So this is just when we're randomly filling the map. We wanted to obey some sort of loose guideline of how much should be filled initially with wall. So this is a percentage. So let's just add this little command here where we can open square bracket and say range 0, 100. So now this integer can only be in the range of 0 to 100 when we're assigning it in the inspector. And let's also create a public integer width and a public int height. Alright, so now I'm just going to create a start method, and inside the start method we can simply call a method we're going to create in a moment called generate map, and that will just be a void generate map. And to start with, all it needs to do is say map is equal to a new integer, and we just say that its size is width by height. Alright, so if we go into Unity now, on this game object here we could specify a width and a height, so say for example 60 by 80, and you can see we can drag up our random full % from 0 to 100. So just as a guess, we considered it about 45 for now. Going back into MonoDevelop, let us now go ahead and create another void called random fill map. So I'd quite like to make this random fill map method work based on a seed. So if we give it the same seed, it will always generate the same map. So let us create a public string seed, and can also make a public bool use random seed, in which case we'll just generate its own random seed each time. So in the random fill map we can say if use random seed, then we can just overwrite the current seed, set it equal to, I don't know what will change every time. We can use maybe time.time.toString. Alright, there we go. And we're going to want to create a pseudo-random number generator. Well, we won't program one ourselves. We can actually use the C# one if we just say using system. That will allow us to say system.random, and we can call this our PRNG for pseudo-random number generator. this is equal to, I suppose we have to say new system.random, and it wants an integer seed. So we need to convert this seed string into an integer. So we'll just say seed.getHashCode. All right, so that will return a sort of unique hash code for the seed. And now what we can do is we can do a little loop to go through each of the tiles in the map. So we can say for int x equals 0, x less than width, x plus plus, and I'll just copy this quickly and call it y less than height, and y plus plus. Alright, so now for each tile we can say map xy is equal to, so now we want to set it equal to either 0 or 1. So let's say that if the pseudo-random number generator, it will give us, we wanted to give us a number between 0 and 100, which we can do by saying, what do we call it, pn pseudo-random number generator. I don't actually like this name really. I'm going to call it something more sensible, like pseudo-random. Pseudo-random.next, we can ask for we can specify basically a minimum value and a maximum value. So we want something between 0 and 100, and if that is less than our initial full percent, that random number, then we want to add in a wall, and if it's greater than it, then we just want to leave it as a blank tile. So our condition is that it's less than our random full percent. Let's put that all in brackets, and we'll use this fancy if-else notation by adding in a little question mark. So if it is less than the random full percent, then we want the map at this tile to be equal to 1. Otherwise, which we say by using a little colon, we want it to be equal to 0. And let's just make sure that I don't have any problems with my syntax. Everything seems to be fine. So we should now be having a map that is randomly filled up. So to check that this is really working as intended, let's create a onDrawGizmos method, and we can just say if the map is not equal to null, then I'm just going to copy this little for loop here. Then for each of the tiles in the map, we first of all want to set our color. Say gizmos.color is equal to, if the map at x, y is equal to 1, then that is a wall tile, so we can set it to color.black. Otherwise, we can set it equal to color.white. All right, and let's create a vector 3 for the position of the gizmo. So that would be, we can call that position, and that's equal to a new vector 3. For the x-coordinate, we'll take a negative width over 2, and we'll add x. And just to make sure things are perfectly centered, we can also add 0.5. And for the y, we'll just leave that at 0, and for the z, negative height over 2. Plus y, once again, just plus 0.5. Alright, so now we can just draw a gizmo at that position. We can just say gizmos.drawCube. And for its center, we just pass in position. And for its size, I guess we can just use vector3.1. Close brackets, semicolon. Let's go into Unity and see if this is working. Probably want to go into top view. Not really. I think The problem most likely is that I've forgotten to call this random fill map from the generate map script. So if we could just do that. Let's try again. I'm going to go into top view, and I'm also going to change from perspective to orthographic. And let's have a look now. Alright, it seems to be generating a nice map. And if we change the fill percent up to say 80, well 78, you can see it seems to have the desired effect. If we change it down to something low like 16, yep, I think we can pretty much say that it is working. Oh, and also since we haven't turned use random seed on, let me just put a seed in here. I'll just use my name, Sebastian, and set this equal to 50, and let's see if we can make sure that this is giving us the same result each time. It's a little bit difficult, but let's just choose a little spot. Say over here, just memorize that, and if we run it again, it does seem to be generating the same shape. And obviously if we click use random seed, it should generate a entirely different shape. Alright, so this is our starting point, and now, as I was mentioning earlier, we want to run this through a couple of iterations of smoothing to actually get a proper cave shape out of this. Alright, so going back to our map generator class, what I want to do is say that the tiles around the sort of border of the map are always walls, because we don't want sort of holes in the edge of our map. It would look quite strange. So here we can say that if x is equal to 0, or x is equal to width minus 1, or y is equal to 0, or y is equal to height minus 1, then map xy is going to be a wall, and otherwise we do our little random thing. Alright, and let me also just correct my butchered spelling of pseudo. It is a E before the U, I believe. Alright, so now we want to do a bunch of smoothing iterations. So let's create a void smooth map. And in our generate map method, we can do a little for loop. For int I equals 0, I less than, I don't know, 5, I plus plus. So I mean, with this 5, as with really all of the values that we'll be using in the smooth map method, you can really just experiment with those, because different values are going to give you different types of cave shapes. So yeah, you can really just play around with the values and with the rules and see what happens. So anyway, I'm using 5, so I'm going to say smooth map, and of course that'll be called 5 times. And inside of smooth map, let's see if we can steal this little for loop here. We're going to want to look at every tile, and one piece of information that we want to know is how many neighboring tiles does this tile have which are walls. So let's create a little method which can figure this out for us. We can call this something like get surrounding wall count. So this will obviously want to know for which tile we want to get this information for. So we'll give it an int grid x and an int grid y. And we can create an integer wall count, which is equal to 0 at the beginning. And we want to do a little for loop. So we'll basically start by creating a int. We can call this neighbor x is equal to grid x minus 1, while neighbor x is less than or equal to grid x plus 1. Neighbor x increments by 1. And I'll just copy this for the neighbor y. If I just select this and hit Command R, I can just quickly rename all of those. And just remember to change the grid x to grid y as well, of course, here and here. So all this is doing, in case you're uncertain, is just sort of looping through a 3x3 grid centered on the tile grid X, grid Y. So we're looking at all of its neighbors. And of course, when neighbor X is equal to grid X and neighbor Y is equal to grid Y, then we'll be looking at our current tile, grid X, grid Y, and we don't want to consider that. So we'll just say if neighbor X is not equal to grid X, or if neighbor Y is not equal to grid Y, then we know that we're not looking at our original tile, in which case we'll say wall count plus equals map neighbor X and neighbor Y. So if a map neighbor X neighbor Y is a wall and is equal to 1, then our wall count will increase, and if it's an empty tile, as you know, it's equal to 0, and well, it will have no effect at all. At the moment, if grid X was, for example, equal to 0, then we'd be trying to get, well, neighbor X initially would be equal to -1, and we'd get all sorts of nasty errors. So we must also check that, let's see, let me do this check over here. If neighbor X is greater than or equal to 0, and neighbor X is less than the width of the map, and the neighbor Y is also greater than or equal to 0, and finally the neighbor Y is also less than the height of the map, then we know that we are safe inside the map, and we can do that calculation over there. If this is an edge tile, in other words, we're trying to look outside of the map, then I just want to increase wall count by 1, just so that we sort of encourage the growth of walls around the edge of the map. So in the smooth map, we can now say int, let's call this neighbor wall tiles is equal to get surrounding wall count x, y, and now we can just make up some simple rules. Let's say that if the, what did I call that, neighbor wall tiles is greater than 4, then map x, comma y is going to be a wall. Else, if the neighbor wall tiles is less than 4, then map x, comma y is going to be an empty tile, and if it's equal to 4, then we'll just stay whatever it was. So let us see what this set of rules looks like. So let's, well, hold on, got an error. It looks like I'm not returning. Yes, I did forget to do that. At the end here, I must just return wall count. Let's go back into Unity. Is that all? Yes, let's run. Okay, so we have a cool little map. And let us just, where's my develop? Let's create an update method. And let's just say every time that we press the mouse, input.get mouse button down 0, every time we press the left mouse button, we will generate a new map. Okay, so I'm just going to change the width to, say, 128 and the height to 72, just so it sort of fits on the screen better. And let's play. And okay, we're getting a pretty nice cave shape. I think the random fill percent is a little bit high. Let's try setting that down to 45. And yeah, these cave shapes are looking much nicer. And we can see what happens if we turn this down, say to 32, we get this rectangular type of cave. Which, you know, I suppose it's got its uses. You might want something like that, I don't know. And going past 50, not so good. So probably the range that you're looking for is somewhere between 40, 47. Yeah, this seems to be sort of generating the best results. Just as an example of how changing one of the rules can change the type of sort of shapes that you're getting, I'll change this from less than 4 to less than or equal to 4. And now if we run, let's see, you can see that the types of shapes are much more, I don't really know how to describe it, but it's less sort of organic. It looks more like it's got some sort of man-made elements to it, which is maybe something one would like. Anyway, so you can see how you can just sort of experiment with those rules and not just necessarily the values there, but you can also go a little bit further. Like, for example, you could, for the first couple of steps, you could do one set of rules, and then after a number of iterations, you could change to a different rule set. And of course, you don't only have to look at the immediate neighbors. You could look at, like, instead of a 3x3 grid, you could look at a 4x4 grid. Whatever, you can experiment with that if you're interested. I want to change this back to how it was with less than 4. So just looking at these different shapes being created, you can see that in some cases there are sort of these little isolated parts, or let's see if I can get another example. Here's a good example. These sort of like one block walls. All of that we'll probably address in the next episode. We might either decide to just delete these unconnected, or rather disconnected caverns, or we might connect them up with little automatic passageways. So yeah, that'll either be next episode, or maybe we'll look at the marching squares first and come back to that. I'm not sure yet, but yeah, I hope you've enjoyed this first episode, and if you have any questions or suggestions, either for this series or another series or whatever, yeah, just leave a comment and I will see what I can do. All right, thanks very much for watching. Cheers.